Okay, so today I will show you how to create this project with 3 gauges, showing the oil temperature, the turbo boost gauge and the oil pressure. And I'm using this thin white display that is being driven by the Arduino UNO that is hidden behind this shield. And as I turn those 3 potentiometers, I'm changing those 3 gauges. The inspiration for today's project is from this set of gauges. Those are from the Ford Focus RS, and those additional gauges are inside the center console with a slightly different appearance based on the model year. I'm trying to replicate this version, which I believe is from Ford Focus RS model year 2015 to 2018. Now, unfortunately, I don't have free hands, but let me try to rotate all 3 potentiometers at the same time so you can see the performance, which is actually really great. It's constantly updating 60 times per second, so the animation is very smooth. I have 2 versions of this project. This blue one is showing the temperature in the degrees Fahrenheit and the pressure in PSI. And this red version is showing the temperature in degrees Celsius and the pressure in bars. The good news is that later in the video, I will show you how to update the graphics so you can have the gauges in pretty much any color and also show any ranges or any units. But before we do so, let's talk about the sponsor of today's video, which is PCBWay. Because if you are doing electronic projects, sooner or later you might need PCBs or maybe PCB assembly or SMD stencils, and PCBWay has you covered. They offer all of those services for a reasonable price, and if you use the link down in the description, you can get 10 PCBs for free, only paying for shipping. On top of that, PCBWay offers CNC machining, 3D printing, or even things like injection molding. So thank you PCBWay, and let's get back to our video. For this project, if you want to follow along, you will need 2 things. You will need this display. This is the intelligent display from a company called DWIN. It's sized 3.7 inches and has the resolution of 960 x 240 pixels. And then you will need the Arduino UNO. Actually, any Arduino board will work, but I'm using the Arduino UNO because that one is very easy to use. Now, when you purchase the display, you can get just the display itself, or you can get the display with the accessories that are including the micro SD card, the FFC, the flat flexible cable, USB to TTL board and the USB cable. And if you have never used the DWIN displays before, I would highly recommend getting the entire package as it will make your life much easier. The DWIN display is what's called the intelligent display, meaning it's not just a display, it also has a microcontroller hidden behind this shielding, and it can store images, it can draw images, it can play animations, it can handle touchscreen, since this is a touchscreen, and so on and so on. So it can do all the heavy lifting by itself. In many ways, it's similar to the Nextion displays, which I have used for my previous videos. I will put the links down in the description. The difference between the DWIN displays and the Nextion displays is that the DWIN is cheaper, has much bigger range of sizes and shapes of displays, and it's also faster. So you might be wondering, what's the catch? Well, there is actually one. Those displays are much harder to use, but hopefully that should not be a problem, since I will describe all the needed steps. And as a first step, let's try to draw an image on the display and not care about the Arduino at this point. First of all, I need to download the software by going to the DWIN website and then clicking the Downloads Tools page. And in here I want to download this DGUS V7647. I believe that the DGUS stands for the DWIN Graphical User Software, so click the download button. And you actually don't need to install the software, just unzip the zip file and click the DGUS V7 executable. That should show you this intro animation. And then this application window. Now if you see everything in Chinese, go to settings and then click this drop down menu and select the English language. Actually, if you have everything in Chinese, you might not be able to see those labels, but one of those tabs should have the drop down menu to change this to the English language. The next step is of course to create a new project, so click the new button. And you might want to create a new project folder and then select it in this file path menu. So let me do that. And the next important thing is to select the resolution of our display, which is 960 by 240. And since I don't see the resolution in this list, I'll just type in the value, so 960 x 240. The thing is that for some unknown reason, I had to set the height to be double the size, so not 240 but 480 instead. Otherwise it was not working correctly, so click the OK button, and that will create a new empty project. Now the project is made from individual screens, and those screens are defined in this area. You can see that right now it's empty, and it is required that every screen has a full screen background image. I have the image prepared in the correct resolution, being the 960 by 480 pixels, and just to prevent any confusion, I've made the needles in the yellow color, So the static image will have the needles in the yellow color, and when we start moving those needles, I will switch to a different color instead. Now if we want to use this image as a screen background, we have to rename the image and start with the number, which will be the screen number starting from 0, so 0 and then some name. And then go back into the software and click this plus icon and select that image and open the image. And you can see that on our screen 0, we are now using this background image that we have just loaded. And I think that's all that I want at this point. I just want to show the static image on the display. However, it's not that simple because this PNG image is not something that I can upload to the display directly. First, I need to have this image in the JPEG file format, and then I need to convert it to a special file format with the extension of ICL. Thankfully, there is a tool to do that. If I go to Settings and then go to DGUS serial port, and then I click the ICL tool, which is for converting images into this ICL file format. I can either select the folder or I can select the individual images, which is something that I will do, so click the Select Pictures and then select our PNG image. Now I've told you that you need to have the image in the JPEG file format, but this tool will actually convert the PNG into the JPEG into the ICL file format. So here you can select the JPEG quality. I will go all the way up to 100 and the sample type to be 444 for a bigger image quality. Then click the Set All to set the quality for our one image. Keep all the other settings to default and click the Generate ICL file. Now there is also a requirement for the file name for those background images. It has to start with the number 32 and then it could be anything. I will call this static yellow gauges and click the Save button. Looks like it was saved, so click the OK button. And if you are wondering why the background images has to start with 32, if you go to CFH Edit, there is this entry saying the ICL address is 32, that's for background images. But let's just not worry about these settings for now. Let's jump into the main application, go to File tab and click Generate. That will show you some dialog, and then click Export. That will again show you some dialog. And if I open the project folder and the DWIN set folder, we have a few files in there that needs to be copied to the display. There is actually also the PNG file which doesn't need to be copied. We only need to copy those bin files and the ICL files. And there are two ways how to copy this to the display. We can use a micro SD card or we can use the USB to TTL board. So let's for example start with the micro SD card method. The process is quite simple. I will insert a micro SD card to my PC, which is this right window, currently being empty, and I will copy this whole DWIN set folder into the micro SD card. And if I open it, I don't need this PNG file, so I can as well delete it, only keeping the bin files and the ICL file, again inside the DWIN set folder. Then you can remove the micro SD card from your PC. Make sure that the display is disconnected from everything and insert the micro SD card on the back of the display. Now we need to provide power to the display, and if you have purchased the display with the accessories, it should be simple. Just insert the FFC cable into the display and into the USB to TTL board. And then connect the USB to TTL board to the USB power supply. And right as I do so, the display will show a white message on the blue background, showing that some files were copied to the display. Then I will disconnect it from the USB power supply, remove the micro SD card from the display, and connect it to the USB power supply again. And as I do so, I see our static image with yellow needles, which is great news of course, and a great first step. And of course the next step is to not just show one image, but multiple images, going from the minimum to the maximum value, showing the animation for individual gauges. And for that we of course need those sets of images, which I've prepared in a tool called Photopea. Now Photopea is a free online graphic editor similar to Photoshop, and I have this file with 121 groups, and every group has a background layer and a needle layer, and the needle is slightly rotated in every single group, going from the maximum value all the way to the minimum value. And what I want to do is to export all those individual groups as separate images. Now you might have noticed that the name of the groups starts with the -e-, and that's quite intentional because I can go to the File, Export Layers, and check this checkbox which will only export me the layers which start with the -e- in the name. and then I can export those as a PNG file format, but what I would like to do is to export those in the JPEG file format, because I did found out that exporting JPEG files straight from Photopea oftentimes creates smaller files. As for the quality, I will try to keep it on some higher value, for example 95%, and click the Export Layers button. This is the content of the exported zip file, having the 121 images going from the minimum all the way to the maximum value for this particular gauge. And we of course want to use those images, this animation, inside our project. So I will go back into the DWIN DGUS project and again jump to the Settings tab and open the DGUS serial port utility. And in here I will go to ICL tool for converting JPEG files or PNG files into the ICL files. And this time I will click the Select Directory button. This is the folder with my exported images, so I'll select that folder, and you can see I have 121 images. And since those are already JPEG images, I will click the Skip Original JPEG checkbox, and that will make sure that none of those JPEG properties will be set. It will just use the original JPEG files instead. So all that's left to do is to click the Generate ICL file, and I want to save it inside the DWIN set folder, and as for the name I will go with 33, and I will explain why I'm using 33 in a minute. So 33, and let's call this gauge oil temperature. I can even say F so I know it's in Fahrenheit, and click the Save button. It will export the ICL file, and I can jump into the main application. In here I will jump to the Icon Show tab, and you've probably noticed that the word icon is being used instead of images, so icon equals images in this tool. And what I want to use from here is the animation icon, because I want to play the animation, so click this tool and then draw the rectangle inside the canvas. And on the right side for the icon file I will select this 33 gauge oil temperature file. The first image should be this image number 0. If I click this plus icon, it will show me this dialog where I can select the icon. So icon number 0, the first one, click the OK button. And the last one should be 120, but I can as well select the plus icon. And again in this dialog, go to the last page and select the last image, which is this one. That will just set the image to be 120. Now we don't see any preview, but if we start moving this rectangle, it will update itself. And you can see that the image is being transparent, one of the color is being transparent, which is not what I want. So I'll set the display mode to be the background display to not show any transparency. Unfortunately, this preview is not reflecting that change, but it should be fine on the display. There are still a few more things that I need to set. I want to stop the animation when the value is 0, and I want to play the animation when the value is 1. And since I want to play it right from the beginning, I will set the initial value to be 1 as well. Now you might be asking what kind of value am I setting, and that's what this VP stands for. So the VP is a virtual pointer, and it sets on which address this variable will be stored. And I want to of course change it from 0 to a different value, for example 1000. And I also want to change the SP value, that's the address where all the settings are being stored. I guess it's the settings pointer maybe. So I don't know, some random value, for example 7000. And at this point, the only thing left to do is to move this gauge to the correct position, all the way to the left side, and I believe that the Y position should be 120, so 120 for the Y position and 0 for the X position. Again, we see the transparent background, but that's only for the preview inside this application. Before I uploaded this to the display, I can test some of those functions of this project by going to Show and then selecting Preview from first. It will show me the warning message that there is no font in this project, but that's fine, I'm not using fonts. And if I click the OK button, now I can see the animated gauge on the left side of the screen, going from the minimum all the way to the maximum value, which was exactly my intention, so it seems to be working fine in this simulator. I will double click the border to close this window. And then now we can upload this to the display, go to File and save the project, and then click the Generate button and click the Export button. And I'm not quite sure if I have to actually click both buttons at the same time, but you know, it shouldn't hurt to click the Generate and Export. And again, that should update the bin files in the DWIN set folder in our project. I've already showed you how to upload the project to the display using the micro SD card, so let me show you the second method using the USB to TTL board. And that's this little board which converts the USB communication coming from this USB port into the TTL serial communication coming from this side. And this is quite common board. I have a lot of USB to TTL, USB to serial communication boards. For example, this one or that one. But what's special about the DWIN board is the connection for the FFC for the flexible flat cable. which means that I can quite easily connect this board to the display, which also has the FFC connector. The USB port should be of course connected to your PC using the provided cable, which has the USB-A connection on both sides. So once this is being connected, we see our static image and we can jump back to the DWIN application. In here I will again open the DGUS serial port utility, which is this one. And in here I will keep the download tab selected because we want to we want to upload things to the display. And I will click the select directory button and select our DWIN set folder, and it will load all the bin files and the ICL files. Now before uploading, I have to click the refresh serial port button and select the correct port. In my case it will be COM number 13, usually it's the last one. Keep the default speed to the default baud rate and click the start downloading button. And that should transfer all the files one by one to the display's memory. And after this is done, just click the OK button. And we should see the very same animated gauge on our display, and I think it looks great. As you can see, the animation is very smooth. Now this display is actually a touchscreen, so what if we try to stop the animation by clicking the touchscreen and then play the animation by clicking on the different spot of the touchscreen? Yeah, let's try to do that. Let's jump back into the DWIN DGUS application. And what I want to do is to set the value on the address 1000 to be either 0 or 1 using the touchscreen. So I will jump into the touch tab, and there are quite a lot of tools to choose from with not so very descriptive names. So you might not be guessing that I want to use this one, which is called the return key code. So I will just click it, the returned key code, and draw the rectangle like so. So when I click this area, I want to stop the animation from playing. And to do that, I will set the value to be 0, so all zeros on the VP on the address of 1000. And I don't want to have any button effect, and I don't want to do any page switching. So go to File and save the project, and then Generate and export the project. And then I can go to the Show tab and click the preview from the first page, and the animation is playing, but as soon as I hit the middle part of the screen, the animation stops playing. However, there is no way how to play the animation again, at least not for now, so I'll just close this window and copy and paste this button one more time, or this touch event one more time. And I will only do one change, and that is to set the key value, the value which I want to set, to be 1 instead of 0. And then again go to Show and the preview from the first page, and it's playing, and if I click in the middle it stops playing, and if I click on the right side of the screen it will start playing again. But you should notice that as I stop the animation from playing, it will jump back to the frame 0 or the first frame, and that's because for this animation icon, the stop icon is set to not reset, and what I want to do is to set it to current icon, so whatever is the current icon, it will stop there. Unfortunately, if I test it again, it will not make any changes, it will still go to the first frame, but that's only for this simulation, it should be fine with the actual display. So let's try uploading this new version to the display. So again, File, Save, and File, Generate, and File, Export. Then go to Settings and open the DGUS serial port. And since we haven't changed the images, only the logic, I can select the files and only select the bin files and not the ICL files. And that will make the uploading much faster because as you can see, the ICL file is about 2 megabytes, but those bin files are fairly small. So open those bin files, select the correct communication port and hit the Start Downloading button. And after this is downloaded, the animation is playing again, but when I press the middle of the screen, it stops playing, and when I press the right side of the screen, it starts playing again. And unlike in the Windows simulation, it stops on the current frame. Now let's see if we can control the animation from the PC and later on from the Arduino board. If I jump back into the DWIN DGUS application, I will again open the DGUS serial port utility. And let me actually minimize this window so I can see the video. If I select the SP Order tab, I can send commands to the display. And again, the first thing to do is to select the correct port. In my case, that's the COM number 13. The speed, the baud rate should be kept to the default one, again because inside the CFG edit, there is this field which sets the baud rate for the display, which could be changed, but we will not be changing it today. And then I want to control the animation, so I want to write the VP, so write the virtual pointer, or maybe it's the value pointer. And I know my address is 1000, so set the VP address to 1000. And since the animation is currently playing, I want to stop the animation, and I will do that by sending 0, so 0, and click the send button. And you can see that as I click the button, the animation immediately stopped playing. And that's because I did send this command to the display, so 5AA5, that's the header of the message that always has to be there. Then the 05, that's the number of bytes I will be sending, so 1, 2, 3, 4, 5, I will be sending 5 bytes. The number 82 is the command to write VP to set the VP. And then we have the address, which is 1000, and the value, which is all zeros to stop the animation. If I want to play the animation again, I can just change the value to not be 0 but to be 1 instead. And if I click the send order button, you will see that now the animation is playing. And again, I was sending this message being the 5A5, so that's the header of the message. The number of bytes, again we are sending 5 bytes. Again we are sending the command to write VP, so 82 is write VP. And then the address again being 1000, but now the value is 1 instead of 0. And this message is quite important because that's what we will be sending from the Arduino to the display, but before we do so, we have to solve one important thing. And that's the fact that with this animation icon component, we can play the animation or we can stop the animation, but in order to use it as a real gauge, we need to be able to set the current image, and that's not possible. So what I will do is I will just delete this component as well as those touch events. And instead of using the animation icon, I will use a different component, being the variable icon, which is this first one. So click the variable icon and draw the rectangle. And same as for the animation icon, the icon file should be the 33 gauge all temperature. But this time I have the access for the minimum value and the maximum value. And the minimum should be 0, which will also show the image number 0 from our list. That will be same as the last time. For the maximum image, I will again go with the last one, which has the index of 120, so click the OK button. And for the maximum value, I can as well go with 120. I mean, I don't need to, it could be 100, could be 1000, but I will go with 120 to match the ID of the image. I don't want to have this transparent, so click the show background. And again, if I move this rectangle, it will update itself. I can keep the initial value to be 0 this time, so the minimum value. But I still have to set the VP and the SP addresses, and since I don't have the animation icon anymore, I can use the same address of being the 1000 for the virtual pointer, for the value pointer, and for example those 7000 for the SP for the settings pointer. Then I will move it all the way to the left side, so X will be 0 and the Y will be 120. And instead of setting the animation to be playing or not playing, I can use the very same touch event being the return key code. I guess I didn't have to delete it, because now I had to set the very same settings, being the VP of 1000, but I can set it to 0 to be the first image, and let me just copy and paste it one more time, and I can set it to 120 to be the last image. Actually, I'm not quite sure about that one, because this is the hex value, and I believe that we were sending the integer value for the image for the maximum value, so I need to first convert the 120 from decimal into the hexadecimal, which should be 78, so let me just change this to be 78 instead. And then try to simulate it by going to the preview from first. And if I click in the middle, it should be the first image. If I click on the right side, it should be the last image. And again, the first image, last image, and so on. But if I want to show the smooth transition from the first image all the way to the last image, I will need to set all those individual in-between states. And I can actually do that with a different touch event. So let me finally delete those two and create a new touch event, which will be this one, which is called the drag adjustment. And that's for like a slider. So just drag a slider like that. And again, we want to set the address to be 1000, so VP should be set to 1000. We want to send the value to be integer value, and we want to be dragging in the horizontal direction, going from the left side to the right side or vice versa. And our start value is 0 and the end value should be 120. And if I simulate this one more time, I should be able to click and drag my mouse to the right side, updating the gauge images, going from the left side to the right side for the minimum to the maximum value, and then going back. And it's not quite obvious that I could be dragging on the right side to change the value, so maybe before uploading this to the display, let's just quickly change the background image. And I can do that by clicking this icon for replacing the image. So just click the icon, and I've already prepared a different background image with this slider, and everything else is black, so open this icon. And I will just slightly reposition our slider to be matching the background image, like so. And then we can try it on the real display, so File, Save, and Generate and Export. Then open the DGUS serial port, and since we have changed the background image, we have to also change the ICL file for the background image. So go to ICL tool and select Pictures, and select our background image. I will again use the best quality, set all, and then generate the ICL file. And again, the first thing has to be 32, but let's just call this background slider and save the image. and then jump into the download section, into the upload section, select the correct port and select the files. And we need to upload all the bin files, and we need to upload a new background image, which is this 32 BG slider ICL file. We don't have to upload these 32 gauge images because that's still the same, we haven't changed it. So click the OK button and upload those 4 files to the display. And once this is finished, we should see one gauge with the slider, and as I move my finger on the slider, I'm changing the value of the gauge. So instead of changing the gauge manually like this, let's try to set it using the serial commands. Again, inside the SP order tab, I will set the communication port to be number 13. I want to write VP on the address of 1000. And if I set the value to be 0, I should show the gauge on the left side. If I set it to the maximum value being 120, which is hexadecimal 78, so 78, it should be all the way on the right side. And if I set it to the half of the value being 60, which is hexadecimal 3C, now the gauge should be exactly in the middle. So I think it's time to take the Arduino and start sending those commands from the Arduino to the display. And I will start in PCBWay, which is a free online Arduino emulator. And since I'm using the Arduino UNO, I will click this icon and create a new empty project using the Arduino UNO. Since I want to send serial commands, I will open the documentation for the serial monitor, and there is a sample code which is sending some message using the serial port. So I will just copy this sketch and paste it into the Arduino project. And if I restart the simulation, you will see that the Arduino is sending this message being the hello Arduino, and it's sending the message using the serial pins, which are pins 0 and 1, 0 being for receiving and 1 being for transferring. As you can see up here, we are setting the speed to be 115200, which is matching the speed of the DWIN board, so that's fine. But instead of sending the hello world message, we want to send one of those messages, for example this one, that will set the gauge to be all the way on the right side. So let me just copy this message in here, and instead of sending the hello world, I want to send this message. So let me just put it inside and restart the simulation. And once I do, I see this message, but this is just a string message. Those are individual characters. What I want to do instead is to send those as individual bytes. So I need to tell the Arduino that those are not characters, those are byte values, and I will do this by escape character X to make sure that this is being treated as the byte value. Like so, and restart it one more time. And now those individual bytes are being sent, and if I count the number of characters, it's 1, 2, 3, 4, 5. But if I look into our code, we are trying to send 1, 2, 3, 4, 5, 6, 7, 8 bytes, not 5. So what's happening? We are only sending this byte, second byte, third, fourth, and fifth byte. We are not sending this byte, which is the byte number 0, which is also the null character, and that is setting the end of the string. So the printline function thinks that this is the end of the string, and it's not sending anything after that. So instead of using the printline function, we have to use a different function, and that will be the write function. And let's just type in those bytes one more time. So 5A and A5, that will be the header. Then we have 05, which is the number of bytes. The number 82 is for setting the command, which is the send VP or set VP. Then we have the address, which is 1000. And finally, we have the value, which should be 0078. And if I restart the simulation one more time, I can now see that I have more characters being 1, 2, 3, 4, 5, 6, 7, 8. So it looks like that we are sending all the data, and this will set the gauge to the maximum value. Let's actually cut it and paste it into the loop function. So I will set it to the maximum value, then I will wait 1 second, which is 1000 milliseconds, and then set it to minimum value. And we know that the value for the minimum value should be 0, and then again wait 1 second. And I think that's all that we need to toggle between the minimum and the maximum value on the gauge using the Arduino UNO. So the first step is to take the Arduino UNO and connect it to the PC using the USB cable. And let's just not worry about connecting the display at this point. Then I will copy the code from the PCBWay simulation, open the Arduino IDE and paste the code in here. Then select the Arduino UNO from this drop-down menu. My UNO is connected to the port 14, and then click the upload button to upload this sketch to the Arduino UNO. And it shouldn't take a long time, it should be done in a few seconds. Now the Arduino UNO is sending the serial message, which you can tell by this blinking, actually shining TX LED. Again, the TX stands for transfer, so it's transferring the data using the serial port. And the TX pin is the pin number 1, as you can see on the board itself. Which means that we need to connect the TX pin, the pin number 1, to the display. The display uses the flat flexible cable, so I'm using this adapter board to connect this flat flexible cable into the pin header. And if I flip the display, I can see the pin assignments. So the first 3 pins are 5 volts, the last 3 pins are ground, and in between are the serial pins being the RX and TX4 and RX and TX2, and I believe that only the 2 is being used. So I want to connect the TX, the transfer from the Arduino board, into the RX, into the receive on the DWIN board. And it looks like that's the pin number 4, so I'll just connect those 2, and then I need to connect 5 volts for the first pin and the ground for the last pin. And as soon as I do that, the display should be powered and it should be toggling between the minimum and the maximum state for the gauge, which seems to be the case, so that's great news and great progress. As the next step, let's try to smoothly play the animation by sending all the in-between values, I mean between 0 and 120. Back in the Arduino IDE, I will create a new integer variable and call this gauge value and set it to 0. And inside the loop, I will increase the gauge value by 1, so gauge value plus plus, that will increase it by 1. And I will say that if the gauge value is bigger than 120, in that case, of course, I want to go back to 0. I only need to send one message, but instead of sending the value of 0078, I want to of course send the value of gauge value. But the gauge value is type of integer that's taking 2 bytes, and I need to split it into individual bytes, but thankfully there's a function for that in the Arduino IDE, and that's called the high byte and the low byte. So I want to first send the high byte of the gauge value, so the first byte, and then I want to send the low byte of the same value that will send the second byte. And I don't want to wait 1 second, I will maybe wait, I don't know, maybe 16 milliseconds, because 1000 milliseconds, 1 second divided by 16 should equal roughly to 60 frames per second, so it should be updating 60 times per second, or at least sending new value 60 times per second. So let's upload it to the Arduino board and see what happens. And it looks like I'm missing 1 bracket, so let me just add it in here and upload it again, and now it seems to be working. And if I look at the display, I indeed see the animation going from the minimum to the maximum value and then jumping back. And while this looks the same as our project 20 minutes ago, now we are controlling the value using the Arduino, which means that I can take the potentiometer and set the value using the potentiometer. And I can simulate the potentiometer inside the walkway, just stop the simulation, click the plus icon and add the potentiometer into the design. It might be a good idea to use the code that is currently being uploaded to the Arduino UNO, so just copy the code from the Arduino IDE back into the walkway simulation. And if I open the documentation for the potentiometer on the walkway, there is a sample code down here, which first sets the pin mode of the pin A0 to be input. So just copy this into our project. So inside the setup function, I will set the A0 to be input. And for that A0, which is this pin, I will connect the signal from the potentiometer. So signal should go to A0, and then of course ground should go to ground, and VCC should go to 5 volts. And then back into the documentation, it's reading the value using the analog read function. So just copy this piece of code into our code, and I will say that our gauge value equals the value of the potentiometer. And I don't need this piece of code, but the potentiometer goes between 0 and 1023, and we want the value to go between 0 and 120. So what I will do is I will just remap it using the map function, so remap this value, which goes between 0 and 1023, to go between 0 and 120 instead. And once we send the message, let me just print one more empty line using the print line function. It will not affect anything, but it will be easier to look at the message. So with this sketch, let's try to restart the simulation. You see that we are sending some message, and as I try to rotate the potentiometer, the last character is changing, so the value is changing. And it's just a bunch of different characters, but hopefully the display will understand this message. So what I will do is I'll just copy this code back into the Arduino IDE and upload this new sketch to the Arduino board. Now the display needs 5 volts and the potentiometer needs 5 volts, and the Arduino UNO board only has one 5 volt pin. So I will use this prototyping shield, which is my favorite shield for Arduino. It only costs around $1 and it will give you more 5 volt pins as well as more ground pins, which means that I can connect both the potentiometer and the display quite easily. And right as I do so, I can start rotating the potentiometer and setting the value of the gauge on the display. So at this point, it's time to move back to the display and add 2 more gauges. And there is something very important that I need to talk about, and that's the memory usage. If I open the documentation, there is an image down there. Let me find it. It's this one, and that's probably the most important image in understanding how the memory on the display works. So by default, the display has 16 megabytes of flash, and this 16 megabytes is divided into 64 different parts or partitions or whatever you call it, which means that 16 divided by 64 is 0.25 megabytes, so each and every line on this image is 0.25 megabytes, and 4 lines together form 1 megabyte. Now in our project, we've uploaded the background on the position of 32, which is this line. This is our background. And then I have created a new file, which was 33 for the gauge, and the 33 starts from here. But just because the gauge file was about 2 megabytes, it's taking this and also 4 more. So this is about the size of 2 megabytes. So the 33 file for our gauge is taking this much memory, which means that if we want to create a new file for a new gauge, we have to start from around here, which will be, let me count, so 33, 4, 5, 6, 7, 8, 9, 10, so it will be around 41. So we have to start from 41, otherwise we might be overwriting the current data for the gauge. If I look at our project, we also have the files 13, 14 and 22. So we are already taking this space, this is the 13, this is the 14 and this is the 22. So those areas of memory are already taken and we cannot take it for our images, which means that we have some space in between here, we have some space in here. We of course have a lot of space on the right side around here, and we might even have some space in here because we are not using any font files. So when we are choosing what should be the number of the file, what should be the position inside the memory, we have to make sure that we are not overwriting any existing data, because otherwise we might be as well showing completely wrong images. And just to stay on the safe side, the file 33 for the gauge images is actually slightly above 2 megabytes. So what I will do is I will start on the position 43. So from around this position, that will be the second gauge, 43. And then I will start on the position 53 for the third gauge. So that's the plan. So let's export those images from Photopea and create those ICL files. So back inside Photopea, I still have this file, and if I open any of the groups, I have the background layer and I have the needle layer, and both of those layers are smart objects that's indicated by this small icon next to the thumbnail. And both of those smart objects are being used in all the groups, which means that if I change it in one place, it will be changed in all the places. And I can open the smart object by double-clicking the thumbnail of the layer. So double-click the thumbnail of this background layer and that will open that background layer smart object. And in here there is the labels group, which is currently showing the oil temperature. Since I want to export the gauge for the turbo pressure, I will hide those labels and show the turbo labels instead. And then go to File, Save Smart Object, and then I can close this file. And in the main file, if I show the other groups, you will see that all the groups were updated with those new labels. Which means that all that's left to do is to export those layers by going to File, Export Layers. I want to export those again in the JPEG file format, with the quality being around 95% or so. Make sure that this checkbox is being checked and then click the Export Layers button. And before creating the ICL file, I will do this one more time. So again, open the background layer by double-clicking the thumbnail, hide those labels and show the labels for the oil pressure. Then again, go to File, Save the Smart Object, and if I jump into the main file, now we should see the labels for the oil pressure. So again, File, Export Layers in the same JPEG file format and click the Export Layers button. So now I should have 121 images for the turbo boost gauge, and I should have 121 images for the oil pressure, which means that I can jump back into the DWIN application. In here, open the DGUS serial port and select the directory. For example, first for the turbo pressure, so select the folder. Make sure that I check the skip original JPEG files and then generate the ICL file. And inside the DWIN set folder, I will name this 43, and this will be gauge turbo boost in PSI. So save that ICL file and then select the directory again. And this time I will select the oil pressure folder. So select the folder, again skip the original JPEG files and generate the ICL file. And for this file, I will use the address 53. And this is the gauge oil pressure, also in PSI. So save that ICL file. And back inside the project, I will delete the slider and replace the background image with just a pure black image by clicking this icon and selecting the full black image, which I've already prepared. Then I will select this variable icon and copy and paste it one more time. The X position should be 320 and the Y should be 120. And of course the icon file should be different. It should be 43 for the turbo boost gauge. And I of course need to change the addresses. So for example, for the VP, let's go with 1100 and SP being 7100. And then do this one more time. So copy and paste it, move it to the right side, set the icon file to be 53 for the oil pressure, and change the VP address to be 1200. And same for the SP address to be 7200. And that's probably all that we need to do. So save the project, click the generate button and the export button. And now it's up to you if you want to upload it using the micro SD card or using this DGUS serial port utility, which is something that I will do. But I will not select directory, I will select files, because again, I haven't changed this file for the oil temperature, so I only need to update files for the turbo boost gauge and the oil pressure gauge, and of course all the bin files. So select those files, select the correct port, and start downloading, actually uploading. And that will of course take a minute or so, but I only need to do that when I change images. And it looks like it's done, so click the OK button. And because I was using the USB to TTL board to upload the new files to the display, I need to disconnect the display from that board and connect it to the Arduino board again. And I can still use the potentiometer to change the value of the first gauge, but I cannot change the other two gauges, at least not yet. So I will add two more potentiometers and connect ground to ground and VCC to 5 volts. And the middle pin, the signal pin from the first potentiometer, is connected to pin number A0, the analog input 0. So I will connect the second potentiometer to the pin A1 and the third one to pin A2. And with everything connected like this, let's jump back into the Arduino IDE. In here I will be pretty much copying and pasting the code, because having just 3 potentiometers is not worth having the dedicated loop. So for the pin mode, let's also set it to input for the pins A1 and A2. Then this gauge value, let's just rename it to gauge 01 value, and of course rename it in here and in here as well. And then I will copy the variable and create 2 more variables, being the gauge 02 value and gauge 03 value. And of course read it from the pins A1 and A2, so this will be gauge 2 and gauge 3. And then I want to send those values to the corresponding gauges. So the gauge 02 value will be sent to the middle gauge, where the address is 1100. And the gauge 03 value should be sent to the right gauge, where the VP address is 1200. Actually, this middle address is wrong. It should be 1100 and not 1010, so like that. And I think that's all that needed at this point, so let's upload it to the Arduino. And that was pretty quick. And I can now use all 3 potentiometers to set the values of those individual gauges. So we are done with the project, but I will still show you one more thing, and that is how to change the graphics of the gauge to your needs, maybe using a different colors or maybe different range. Well, that's up to you. So let's jump back into the Photopea and let's change the middle gauge, which is for the turbo boost pressure. So this is the Photopea file, and again I have the needle layer and I have the background layer, and I can double click the needle layer, and I can very easily change the color of the needle by just double clicking the needle layer and then selecting the color overlay and changing a different color. But I probably don't want to change the color of the needle for now. What I want to do is to just use this blue color for the rest of the gauge. So I will click this icon, this swatch, and click on the blue color to get the color, and then close the needle. And then open the background layer, the background smart object, by double clicking the thumbnail. And let's just, for example, say that I want to use this blue color for this outline. So I'll locate the outline, which is this layer, and I will double click the layer and apply the color overlay. And of course use our blue color for the overlay. And I might be also changing color for this part, so do the same thing, double click the layer and then add the color overlay. But this blue color will make the needle invisible. I will make it slightly darker, maybe like so. So click the OK button and OK button and choose the correct labels. So for the turbo pressure, and let's for example say that I want to change the range, not going from 0, but for example from -10. So I'll just double click the text layer all the way to 40 or maybe 50, depends up to you. Then I will go to File, save the smart object and close that file. And you can see that the main file immediately updated with the new colors and new ranges. So all that's left to do is to export those images by going to File, Export Layers in the JPEG file format, 95% quality, and export the layers. And then open the DWIN DGUS application, open the DGUS serial port, jump to the ICL tool, click the Select Directory button, and this one includes the exported files, so select that folder, check the Skip Original JPEG files, and click the Generate ICL file. And I will use the very same address as for the current turbo boost gauge, which is 43, but I will use a different name, for example with the blue suffix, so I know which file is which, and save it. And then all that's left to do is to just connect the display again to the USB to TTL board, jump to the T5L download, and I really only need to replace one file, so select the files, and that's this one, the 33 with the blue version of the gauge. So open that file, Make sure that correct port is selected and start downloading. And after a minute or so, a new file is uploaded to the display. And the display immediately reflects that change. You can see that we have a new range and we have the blue outline. I need to again reconnect it to the Arduino board. And it looks like that everything is still working as expected, which is great. I think that the next steps are pretty clear. Instead of using potentiometers, we would connect the Arduino to the real sensors or to the actual car, but that's something for the next video. For now, that's all I have. If you have any questions or comments, please put those down in the comment section. As usual, all the source files are on GitHub, the link is in the description. Thank you very much for watching and I hope to see you soon. Thanks and bye.